Okay, this is our last example before we summarize all the concepts that we have looked at. So for this one we have y equals negative 3 times 1/2 to the exponent x plus 3 and then plus 2. And again, what I want you to notice is where the exponent is and what the base is that it's being applied to. So I can clearly see that my exponent here is x plus 3 and it's being applied to a base of 1/2. So 1/2 is actually going to be our base function. So here's our base function. Y equals 1/2 to the exponent x. So that's actually our base function. All the other numbers that you see in this equation are the different transformations that are being applied to the base function. So the negative 3 is one transformation. The plus 3, well, negative 3 is actually two different transformations. The plus 3 on the exponent is another transformation, and the plus 2 at the end is our last transformation. Okay, horizontal asymptote. Where's your horizontal asymptote normally? Well, y equals 0 is where it normally is, but because the graph has been shifted up 2 units, I know that the horizontal asymptote also moved up 2 units to y equals 2. Now, before I do any other work, make sure that your exponent part, where all your horizontal transformations are in factored form. And if they are, we're good to go. And in this case, they are, so we can continue looking at our key points and then looking at our transformed function and then plotting our points and graph from there. So here we go. So we have x and we have y equals 1/2 to the exponent x. That's our base function based on what we had up here. And so again, we want a point to the left of the y-axis, a point on the y-axis, and a point to the right of the y-axis. And we can apply the different transformations. So now we have 1/2 to the exponent negative 1, 1/2 to the exponent 0, and then 1/2 to the exponent 1. Now, this one's easy to do because anything with an exponent of 1 is whatever we started with. So this is 0.5, so I'll start by writing that, which is a half. The middle one's also easy because any base to an exponent of 0 is equal to 1. Easy breezy. And then the last one is 1/2 to exponent negative 1. And if I apply my exponent rules to this, I'm going to write the reciprocal of the base, which is 2, to a positive exponent. So that gives me a result of 2. So there's my key points for my base graph. And so remember also that this base graph is a value of b that's between 0 and 1. So this is a decreasing function to start. So just to remind you again, look back at this summary that we had earlier. When the base is greater than 1, we expected an increasing graph. When the base is between 0 and 1, and in this case ours is, we have a base of a half, we're expecting a decreasing graph. And if you look at the values of y that you have, as x is getting higher, y is getting smaller. That's how I know I'm on the right track. So let's apply some transformations. So let's take a look at our x value. In terms of our x values, the exponent tells us where all the horizontal transformations are. And the only horizontal transformation I see here is a shift to the left 3 units. So all the x values are decreasing by 3. In terms of the vertical transformations, I see a reflection, a stretch, and a shift down 2 units. So I know that the y values are going to multiply by negative 3. And then I'm going to add 2 since the graph is moving up 2 units. Now let's figure out our points. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. Negative 3 times 2 is negative 6 plus 2 is negative 4. Negative 3 times 1 is negative 3 plus 2 is negative 1. And negative 3 times a half is negative 1.5 plus 2 is 0.5. So there's all our key points. And you'll notice again, because there was a reflection in the x-axis, you'll notice that all your values of y are lower than your horizontal asymptote. That makes sense because the graph has been reflected along the y-axis. Okay, so I'm expecting the graph to be below the horizontal asymptote.